Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right. So, title of today is Volumes of Revolution Part 1. This is like going to be a 3 or 4 part thing. So, coming at you, the revolution will not be televised. It will be on your computer on YouTube. Check it out. So, here's the problem. Pause and write it and draw in your notes. Consider the region bounded by y equals x to the third divided by 8 plus 1. And x equals -2, x equals 2, and the x-axis. So here's the picture of your function, whoop, like that. What if you took this region right here between -2 and 2, all this stuff right here, and revolved it around the x-axis? What would that look like? Yeah, it might look like something like this. Let's actually see. So let's go to our notes, shall we? So here's my notes right there with my title and everything. So what if I took this region between -2 and 2, so this region right here, and just revolved it around the x-axis. So if I were to draw a mirror image, it kind of look like that. And so I'm taking this and you're revolving it around the axis, like that. And you get a three-dimensional shape that's actually totally solid. It looks like there's a hole in it, but it's actually totally solid. So you take that and you rotate it around. So, how do you find the volume of this thing? How would you do that? Well, let's do the same thing we did before. Let's just take a slice. So I'm going to take a slice. It looks like this. And it's three-dimensional. So this width is dx, and remember the volume of a slice, the volume is always the area of the base, or the face right here, times the height. So in this case, it's going to be the circle, pi r squared, not a semicircle, but a full circle right there, so all these are full circles, times dx. Okay, so that's going to be pi, the radius is right here, so that's the radius. But the radius is also this, of all of these, infinite amount of circles. So that's just the top minus the bottom, or just the area under the curve. That's all it is. So the radius is just the area under the curve. So the radius is just the function, x to the third divided by 8 plus 1 squared dx. There we go. So now the accumulation of all these slices, an infinite amount of slices between 2 and -2 to make up this. So the full volume is going to be the integral between -2 and 2. Where did I get those? On the problem. It tells me between -2 and 2. And my integrand is pi x to the third divided by 8 plus 1 squared dx. Bam. Put in the calculator, da-da-da, and you get your volume. Cool. Let's try another one, shall we? Oh, yeah. Here we go. Like these little scribbles my daughter got into my notebook. They're really pretty, aren't they? Thank you. So, find the volume of a solid generated by revolving the region bounded by y equals x squared plus 1, y equals 0, and x equals 5 about the x-axis. Pause the video and write this down. Alright, cool. First thing we gotta do is draw a picture. Here we go. So draw the picture. So y equals x squared plus 1 looks like this. So you start at 1 and then it's a parabola. So y equals x squared plus 1. Looks like that. Y equals 0 is just the x-axis. So that's that. And then x equals 5, let's say, is like right here. Okay? So x equals 5. So this region is where we're talking about right now. So this region. So we're going to take this region, we're going to revolve it around the x-axis. So no problem. So I'm going to draw like a mirror image right here. And so now you're going to revolve it around the x-axis. So it actually looks like, go back to our notes. So here's the problem right here. And it looks like this. Ooh, that's kind of cool when you revolve it all the way around. So How do you find the volume of this? First, you get a slice going. Here's the radius. So the volume of a slice is going to be pi r squared times dx, which is your infinitely small width. So that's going to be pi r, which is top minus bottom, which is in this case is just the area under the curve. Again, x squared plus 1 squared dx. And so now the entire volume of this whole shape is going to be the integral between 0 and 5, because we started 0 and 5. And we have pi, wait, maybe this is the idea, pi x squared plus 1 squared dx. There you go. Questions? Let me know. There you go. All right, let's do another one, shall we? Boom, here you go. Find the volume of a solid generated by revolving the region in the first quadrant, bound by y equals negative 2x plus 8. There's more scribbles from my daughter. Y equals 0 and x equals 2 and the x-axis. So here's the problem right here. Sorry, y equals 0 and x equals 0. My bad. About the x-axis. So I want you to do, so there's the whole thing. I want you to try and do this problem on your own first, okay? Pause the video, see if you can do this one. Ready, set, go. All right, let's see if we did it. Okay, so this is, let's draw the picture. So y equals negative 2x plus 8. So we start at 8 right here, and the slope is negative 2, like that. So here is your region, because y equals 0, bam, x equals 0, bam, and the x-axis. So we got all, so revolving it around the x-axis. So this right here, we revolved around the x-axis like this. So it's this region that's being revolved around. So let's get a slice. Let's get a slice, a nice little slice right here. So this is, sorry, not that part. This part is your radius. In that case, it's just top minus bottom, or in this case, just the area under this line right there. So my volume of a slice is going to be pi r squared dx, infinitely small width, because there's an infinite amount of circles right there that we're making. And so it's going to equal pi times negative 2x plus 8 squared dx. All right, the entire thing is going to be the area between 0 and, what is that point right there? It doesn't tell you here. How might I get it? When a function touches the x-axis, that's called a 0. So I'm going to set 0 equal to negative 2x plus 8 minus 8 minus 8. I think you know what is going to be. So negative 2, divide both sides, and x equals 4. So this is 4. So the integral between 0 and 4 of pi negative 2x plus 8 squared dx. That is my volume. Hopefully you got that. Nice. You ready for another one? A little challenge? Yeah, no problem. Here you go. Need a new page. Bam. Here we go. So same problem. Find the volume of the solid generated by revolving the region in the first quadrant. Boom. Bounded by y equals negative 2x plus 8. Bam. Y equals 0. X equals 0. And the y-axis now. So now we're revolving it around the y-axis, not the x-axis. Alrighty, let's get a picture. No problem. Let's get a little picture, 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 picture. Check it out. Okay, so here is my picture from before. Here's my line. And so this is 4, this is 0, and this is 8 right there. Remember, it's because the y-intercept is 8. So here is the area right here. What are you going to do with it? Revolve it around not the x-axis this way, but we're going to revolve it around the y-axis this way. So So I'm going to draw a little mirror image right there. And so this is being revolved around the y-axis that way. So you got a little cone shape. Cool. So here's my slice. Now it sits like this. Okay? And now here is my radius. So my radius actually goes this way, goes horizontally. So what is that? How am I going to do that? Oh, I know. I'm just going to find the inverse. So this one's going to be in terms of y because I'm going this way. And so I'm going to find the inverse. So I do that by just solving for x. So minus x on both sides. So minus 8 on both sides, my bad. Y minus 8 equals negative 2. Oh, running out of lead. Negative 2x. So I'm going to divide by negative 2, divide by negative 2. And negative 8 divided by negative 2 is 4. And y divided by negative 2 is minus y over 2 equals x. Cool? So that's going to be my radius right there because that's going to be top minus bottom. Okay, so my volume of a slice in this case is going to be pi radius 4 minus y over 2 squared times dy. Right there. Sorry, it's scrunching up against that other work. My bad. Oop. Pencil ran out of lead. I'm just going to use this pen right now. No problem. Okay. So the volume of a slice looks like that. Okay, so now the volume of the entire cone shape right here, when I rotate it, is going to be the integral between 0, not 4, but, 8, because all of the horizontal circles go from 0 to 8 on the y. Bam. Okay, pi times 4 minus y divided by 2 squared dy. Don't forget the dy. That is the width or the height of all of these discs right there. Okay? And boom, we done. Yeah. Cool. All right, so now we've done it a bunch of different ways. And so now what I want you to do, that's what it looks like right there. That's the picture we just created. All right, so see where it says homework right here? Here's where your practice is. You see this? Bam. Example 1, example 2, and you have 1 and 2 right here. I want you to do these right now, setting up the integrals, and see if you can get them. Okay? Answers will be posted on the website. Ready, set, go.